Evaluate the definite integral. And they give us this integral. So how do we do that? What is an integral? It is an antiderivative. So we got to go, okay, so antiderivative. How do we do that? We add 1 to the power, right? Instead of subtracting 1, we add 1. Comes x cubed, and then we divide by that number instead of multiplying by it. Okay, next part, minus 8, and then this is a 1 power, so we add 1 to it, becomes x squared, and then divide by that number. And then the third part, plus, and that's going to be, oops, I'll change the color there, 10x, right? Because, why is that? Because the derivative of that will go back to 10, won't it? And now we evaluate that between 3 and 5. The lower bound is 3, the upper bound is 5. And so what that means is, in fact, let's actually clean that up a little bit before we do. This is well, I'll read it, make it nicer. This is 5x cubed minus 4x squared plus 10x. So there's the antiderivative. We're going to evaluate between 3 and 5. So what does that mean? So what that means is we're going to plug in 5 there, there, and there. So we'll get 5 times 5 cubed minus 4 times 5 squared plus 10 times 5. And then minus, and now we plug in 3 there, there, and they're plugging the lower bound. And there's a subtraction between them. So do the whole function twice, once with the upper bound plugged in and once with the lower bound plugged in. And you subtract the results. It's a little bit tedious. You can go to Desmos and get your numbers. And that's probably what I would do to save time. Yeah, I'm able to do that. 5 times 5 cubed. Here we go. 5 times 5 cubed. Bracket. 5 times 5 to the third power. 5 times 5 cubed. Minus 4 times 5 squared. Minus 4 times 5 squared. Minus 4 times 5 squared. Plus 10 times plus 50. Let's go plus 50 plus 50. Close parentheses. Minus. And the other one is 5 times 3 cubed. 5 times 3 cubed. 5 times 3 cubed minus 4 times 3 squared. 4 times 3 squared. Whoops. Squared. It's 4 times 3 squared. Plus 30. There we go. 446. So that's just our answer on Desmos. 446. Was that the answer at the top? There it is. And so there we go.